Okay, welcome to everybody. This is the Radio Astronomy SIG for TAAA. My name is Sandy Nichols, and with me I have also the alternate here, Gary Steffens. And right off the bat, I'm going to turn it over to Gary.
Okay, so we've asked Bill to share his telescope adventure. I met Bill, gosh, what, 6 years ago
Yeah.
through a common interest in eclipsing binaries, and uh, and after that, I don't know. I started playing with radio astronomy and told Bill about it, and he got all excited and started getting into it as well. And so he's up in Flagstaff, and I don't know what else to say except that Bill's going to take it away and give us a presentation on what he's got up there. So go ahead and
Yes.
share your screen and
All right. Let me see if we can get technology to work again here. All right. Does everybody have my screen?
yes.
All right. Outstanding. We're working. Okay. So yes. And I want to thank Gary also once again for him getting me involved with this. I actually had no idea that this existed. I knew about radio astronomy, but I didn't know that amateurs could actually do things with this sort of stuff. And when he showed me his antenna and what he was doing, and I thought, wow, he's got a waveform on there. How in the world can that happen? And I thought, yeah, this is really cool stuff. And so I thought, yeah, I need to do this. This is good. This is a good retirement project. So what happened for me is I'll get into my background here, and I'll just go into that. Along with what Gary showed me, I didn't know anything about radio astronomy, and um, my dad is a been a ham guy for many decades. He's at 92 years old, and any radio stuff that was radio oriented, I always kind of learned from my dad. And I mentioned it to him, and so he kind of started telling me a little bit about radio astronomy. He has a little bit of a background in antennas and stuff like that. And so and then along with Gary, I started cruising on the net there and looking and seeing what I could learn from this. And came across some of the software defined stuff, and I thought, wow, yeah, this is pretty good. So I think what I'm going to do is, create something, with a small dish, and make that work. And so I started going through all that, and so I read this book a little bit. I don't know if you can see this. I got this from Amazon. It actually came from a university library, and I thought, wow, that's pretty technical. Yeah. In any case, I'm definitely a beginner, and one of the reasons why I was really happy to be joining up with this club, with your club, with this club in this discipline, is to learn, expand my background, and learn from you guys and anybody else that's in this subject, and improve my skills, and in turn come up and do different projects as they get smarter in this. Um, so that's kind of it in a nutshell. And I'm kind of maybe like some of you. I'm just kind of going along and looking for an opportunity to collaborate and say, hey, okay, this makes sense. Can I do this? What's my data look like compared to yours? All right, so my next thing here is what I'll chat about here is why I chose the Spectre Cyber 2. there's kind of an interesting story behind this. I didn't even know about this thing. I was looking around, working with Gary at different times, and I actually bought a Air Spy software-defined radio and a few other components. The Sawbird, I've got one of those. You can see that. It's sitting here. And I was looking for parts. I was looking for information. And I thought, well, I got this pretty well set together. And so now let's look at dishes. So I started looking at different dishes that were on the internet and eBay. And I found a listing on Craigslist for a 3-meter dish down in Tucson. And, I'm sorry, Phoenix. And I was all giddy, and I ran into my wife. And I said, we got to go down to Phoenix and get this dish. The guy only wants $125 for it. And when I was looking at these dishes, they were $1,000 and above. And this is an old C-band dish that you'll see here in a minute. And so anyway, I went down there and I brought the dish back. I looked like a real spectacle going up the freeway because the dish was all assembled when I brought it up. And I had to tie it down in the back of my little trailer. And I don't know how the cops didn't see me, but they didn't. So I finally got it home, and I said, okay, well, I've got this big dish. Now, can I use this Air Spy and these little components here to do this? And that's when I ran into Radio Astronomy Supplies, just by accident. And so I started talking to the guys over there. They've been in business for a long time, but they kind of defunct here. They don't really have a website running anymore, but they actually sell things. And so I say, well, what the heck? I'm going to collaborate or talk with these guys and find out what I can, if I can use what I have here with this Spectre Cyber system that they have in their website. Well, anyway, long story short, he twisted my arm. He says, Bill, he says, why don't you let us sell you some of the components for the Spectre Cyber, and you'll be off and going. It's basically turnkey, and you're going to be off and running. And they said, okay. I said, well, how much is this going to be? And I'll give you the magic number here in a few minutes. So I started getting parts, and so then my Air Spy and the software-defined stuff was kind of put on the back burner. And so then I had a Spectre Cyber 2. And I had to build the antenna. As you'll see, I'll get more into that and make all that work. I spent a lot of time working with Carl. He's the engineer on this. And he helped me quite a bit get the system running. So then that's it. I've had it now for about 4 years, and it is done really well. I've had no problems with it. But that's how it all happened. Again, I never was wanting to get something like this, and I wanted to keep something much simpler with like a scope in a box or something like that. But I thought, well, crap, I'll just get this. And my wife said okay, and so I have that. But we'll get more into the nuts and bolts on that as we go down here. So some of the projects that I would like to do in the future is, first of all, my goal is to learn more about the Spectre Cyber system. And also my goal would be how to integrate a software-defined radio within that system, if that's possible, or use just the antenna and just use that for the receivers without the Spectre Cyber. I always had an interest on mapping the Milky Way arms. I kind of looked into that a little bit, but I also discovered that it's extremely complicated. And I don't know how how if I will be able to do that or not, or I have the time to do that. So that's a couple of things right there, and projects that will be coming within this program that we're in right now. Anything that's down the line there that I would like to get involved with, that maybe some of you guys are involved with. So I've got kind of an open door on that and what I would like to do with projects and my goals with this. I think I told Gary I recently joined up with Sarah. I think it was $20. I joined up a month ago, and my wife showed some interest. I told her about space weather, and my wife has always been interested in space weather. She watches the Weather Channel all the time. And I said to her, I said, you know, you could watch space weather. And so she got excited about that. And she says, well, I want you to order the stuff. And I said, okay, you're gonna take up this program. She says, yep. So we have 2 super SIDs on the way. We ordered 2 super SIDs with a wire, and she's helped me wrap antennas before, bless her soul. So she's going to help me. We're going to do this again together. So she's going to head that project up and get all that working.
Hey, Bill, what does SID stand for? SID?
It's sudden isospheric disturbance. Yep. Yeah. So apparently, as you may know, real briefly, I read it. It's really interesting how this works. But there's these transmitters around the world that generate like these 25, 30 kilohertz radio waves. And they use them for sonar, okay? And as a side effect, the people that look for space weather or with these radios, what they look at is apparently how it goes is if there's an outburst or something happens, it affects the ionosphere layers, and what will happen is there's a blackout that occurs, and so your signal isn't reflected back. So there's a disturbance in the reflected signal coming back to your receiver, and it's represented as a spike. So that's what I know from my simple reading about it. So yeah.
Bill, this is Sandy. Yeah, actually, that Super SID project, I almost think we should do a whole session on just that alone. It's really quite fascinating.
Yeah. No, I agree. When I saw that, and I've made antennas before, but this really looks interesting. And I told my dad, I said, man, I'm going to just take antenna and wrap around my whole 2.5 acres and just and see what happens, because I live in a very RF quiet area. So I have a lot of things I'm thinking about what I want to do, and understanding if the antenna needs to be, if it's a loop antenna, does it need to be directional, or is it need to, can it? I mean, with that, when you're talking about that frequency, it seems like directionality of the signal would be kind of not really a big factor, but that's just my amateur guess at it. So
no, you're right.
So anyway, we got that coming, and I suspect we're going to have a SID antenna up by my radio telescope within the next couple of months. So yeah, so that's another project coming down out of all my other projects. All right, so now let's dive into the Spectra Cyber Radio Telescope a little bit here and kind of go through a little bit about what this thing does, and it's in how different it is from the radio defined system. All right, so it's built by Radio Astronomy Supplies, as I mentioned. It's a purpose-built radio telescope designed by Carl Lester and Tommy Henderson to receive a 21 centimeter 1420 megahertz signal from space. And then I got on there, can be purchased from radio astronomy supplies. We'll get more into that in a minute. So yeah, it is definitely purpose built, but we'll get to the next slide in a minute. There are some exceptions to what the customer can have those engineers do for you for your science goals. It utilizes 5 major components, and we'll look at that here in a minute. Requires a lot of space for installation. So we're talking about a 3-meter dish, and as you'll see with mine, I moved it away from a lot of the AC hum and tried to isolate it as much as I can away from the building. It requires a 12 volt and 115. Those are relatively simple. Another thing that's good about it, the software is very intuitive and it's free. And it runs on Windows 10, 11, and I think there's also on GitHub, there's a Linux version, Gary, on this. I think that is true. Requires some assembly and antenna design, and we'll get to the antenna pictures in a minute. User will need to buy an antenna. Talking to the developers on this, they don't suggest you go anything lower than a 3-meter antenna. So I'll take their word on that one there. But I imagine, you know, if you wanted to, you probably could go to a smaller antenna. So I got down here, customer specific design, different frequency response, feed horn, antenna design, etc. Now, the customer will, if I tell Carl that, well, let me tell you the story real quick here before I go into that. Is that BYU University had radio astronomy supplies build them a very unique receiver. And what they wanted to do is look at something called OH masers. And but they also wanted to look at the neutral hydrogen. So they wanted to look at both of these things. So that required a different receiver and some different feed horns, I would imagine. So it's called hydroxyl molecules. And I cannot tell you what that is, but that's what they were interested in looking at. And that's at 1.6 gigahertz. So 1.4 to 1.6. So they had another antenna tuned to 1.6. So Carl and his company designed a receiver for those guys to do what they wanted to do. So there's that option, and I don't know how far and how low or how high they will go on what your needs are, but they seem pretty flexible in that area. If you have any questions, just jump in as I'm going along here. Okay, so now the cost. So I'll tell you my story here. I got mine in bits and pieces, I guess. I got the what they call the front end, or the front end, which is the well, I'll have to show you the picture of that. But you can buy the all-up system right now. They start at about $1,800 and go up to $4,000. And that's not the antenna. That will include the receiver. Well, the software is free, but you get they call the down counter. You get the receiver, and you get the very low noise amplifier that goes on the feed horn. And I think they also will give you the feed horn. So yeah, it is definitely more expensive than the other stuff we've been talking about. But I did get mine a little bit cheaper than that, but he told me if I were to do it again, he's short on parts. But he will definitely work with people like ourselves that are doing it, especially for outreach and for education and stuff like that. Both these guys were college professors, and so they very much are in favor and support those learning about radio astronomy. The availability, it's made to order, so you have to, like I did, I told them what I wanted to do. I wanted to keep it simple and tell him I just want to look at the 21 centimeter band. He goes, okay, sounds good. And he sent me everything I needed, except the coax. You see the power supplies I had to buy, and I had to then design the antenna and put the stuff on there and make all that work. So yeah, the cost is definitely a little bit higher on something like this. All right, let's move on here for a minute, see what our next, okay. So here's what I'm currently using, okay. This system, the Spectre Cyber system, has other features, other things you can buy into. But with mine, to make mine work, this is all that's required for me to make my system work. And of course, I got the 3-meter parabolic dish that was supplied by me, the 21 centimeter feed horn. That came from RAS, or Radio Astronomy Supplies. Low loss coax, LMR 400. This is a very, very low loss coax. He says, do not use anything that's has any higher impedance than that. He says, keep that. I have 100 feet of that. And I've got a serial to USB converter. There's a serial port on the receiver end that you have to convert to USB. Then I've got the very low noise amplifier that was supplied by RAS. And let's see here. The computer I had to supply, obviously. And then we'll get into the Spectre Cyber back end and front end. Those two components were supplied by RAS. The software was free, as I mentioned. I threw this in here. I don't know if I should have, but I supplied these attenuators for viewing the sun. And I'll explain what this calibration is when we get down to the slides here a little bit, why I have these attenuators here and what I'm using them for. Okay, now let's go and take a look at the interconnect on these components that we're talking about here. So yeah, I had to get pencil and paper on this. I could not find anything, sadly, on Spectre Cyber's manual or website on any interconnect. They have on something on their manual, but I didn't see anything in there that made any sense to me. It was left a lot of parts out, and so we'll go through this here, okay? And you can see what I've got. Now, these are the 5 components that I mentioned. So we got our dish out here. Now, this is considered the front end, okay? And then we have our very low noise amplifier right here in the front. This amplifier is powered by 12 volts. And this amplifier is got a very, very narrow bandwidth centered around the 21 centimeter band. This has been designed for using it for a radio telescope. Okay. And then I have the 100-foot coax then coming to the down counter. Now the down counter, what it's doing, it's actually a super heterodyne is what it is. If there's any ham radio guys in here, that's what this does. So then this narrows the band down to 70 megahertz IF. So now we're eliminating a lot of other bands outside of interest. And we're squeezing this down now to a 70 megahertz FIF. Now that's become our intermediate frequency, or that's going to actually become our 21 centimeter rest. That's what that's going to represent now, and as you'll see here in a minute. And then we come into the back end, which is now the Spectre Cyber. It comes into here. We have the receiver. We have a lot of filtering. I tried to pick Carl's brain. He told me, but I didn't have the brain cell capacity to absorb everything he told me. There is a receiver in here with a lot of mixers, and there is one important item in here. It's called a square law detector. I got it out. Square law detector in here, and I will give you an explanation for that here in a minute. And along the side of the square wave detector is a lot of filtering, and we won't dabble too far into that right now. Okay, then that outputs into a USB converter, which serial to USB, and then that goes into the computer software. And that's mainly it right there. Yep. And this is RG172. I've got between these two boxes right here. Now there is one thing that I guess I'll mention on this is, we talked about in some of the other meetings about these components being temperature sensitive. And this system right here, I'll show you the picture here in a minute where I have it mounted. And it really should be in a controlled room. And one thing I've noticed is that when it's really hot, there's, if you're familiar with germanium transistors, they have a very, very high drift factor. And that's the case. So the amplitude changes quite a bit when it's hot, and it'll do squirrely things like go the other way when it's cold. Or it'll get better when it's cold and get worse when it's hot. So there are a lot of those in here that he's used to make this thing work. Any questions on this?
No.
Yeah, I've got a question for you. The VLNA, that's doing the same thing your Sawbird does, right?
The what now?
That's doing the same thing your Sawbird does, right? Your LNA, you mentioned earlier you have a Sawbird there. Sawbird,
Oh,
there's a Sawbird that is for the neutral hydrogen, and
right.
it's doing the same thing. It's amplifying and filtering.
Yeah,
So,
yeah.
so
This little guy.
yeah,
Yeah.
that one, right.
Right, yeah. Yeah, he would be placed right in here. If I'm thinking right on that, right, Gary? You're putting the Sawbird between the antenna's output, right?
Yeah, that's right.
Okay. Yeah, so this if you wanted to call that the Sawbird, that's correct. That's it. That would be the substitute for the Sawbird is this one right here, right?
Well, this whole configuration looks almost exactly like scope in a box.
Ah, interesting. Yeah, it really is familiar now that you mention it. Yeah.
Yeah, those two boxes, your down converter and your Spectre Cyber, I guess those represent what's in the RTL SDR dongle.
Oh, yeah.
Yeah, I think that's what we're saying, or that's what Sandy might be saying.
Yeah.
And yeah, I'm right, Gary, because I just, we were talking about the heterodyning is that I know the Air Spy system has that in there. So they definitely have that in there. So yeah, this little box right here is pretty amazing. And that's one of my future goals is to come back to the Air Spy and just see how that would work and come up with an alternative to this.
So the Spectra Cyber is really the receiver. Is that right? Is that correct? Or is it the
Yeah, I think the Spectre Cyber is, yeah, if you look at it, yeah, is really the receiver or the back end. It's where the square law detector is and the filtering and stuff. Yeah, that's what's going to parse out the signal and make it work, right? Yeah, I would say that's correct statement. Yep. Yeah.
Okay, thanks.
Okay, now let me see what else I got in here in my bag of tricks here. All right, I'm going to show you some pictures here. And then we can kind of reflect back onto some of the other stuff that I talked about there. This is the antenna. This is what I carted down the freeway, the 17, to get to my house. It's an old C-band TV antenna, as you probably noticed there. And so what I had to do, this is probably the most work I had to do on the entire system, is I had to figure out its focal length, which wasn't too hard to do. And then I had to then use this feed horn. I got a closer view of that. This feed horn here, and I had to mount it on these poles here at the right focus point. And then what I did here is I got the square ring up here, and I can actually slide this square feed horn back and forth, and I actually focus the antenna and get the optimum signal. Okay. So that's the antenna, and then I've got the feed lines. You can't really see it in it, but they're taped to the side right here, and they run off here and go all the way down the yard to inside of my observatory. This right here is the close up of the feed horn. As you can see, I got these copper rods so I could bend them and make them conform to what I wanted to do. Low noise amplifiers here hooked on. I have you probably notice a scalar ring on there. That's to keep spurious signals from coming in. In other words, keep anything from the outside. It helps. You'll also, this white wire right here powers this amplifier. And interesting thing about when I got the feed horn, it was pretty heavy. And I looked at my wife and I said, God, how are we going to put that on there and not have it flop around in the wind? And it took me a couple of weeks to think about how I was going to do that, because when I first mounted that on there and I put the dish on edge, like the other picture there, the feed horn just sagged way down. It wasn't even where it should be. And so you'll notice on the picture here, I got these little wires right here. And so what I do here is I have 4 of them, and I tense these wires when it's laying flat on the ground. And then when I pick it up, it's still aligned. So that's how I got around keeping the horn from flopping over. When it's getting close to up on end, I had to put these wires on here to pull its mass upward to keep it aligned in center and in focus. So yeah, that was it took some time to get everything working on that, but it works really well.
Hey, Bill,
Yeah.
to your copper support that's in the picture is connected to that one little arm of your dish. Does that deform a lot? I mean,
What now, Gary?
So you have those 4 arms, those copper, I guess, are copper pipes or something
Oh
connected
yes,
to the dish.
yes.
Does the weight of the feed horn, does it actually deform the dish itself a little bit?
No, interestingly not. This is 1/4-inch aluminum plate. Okay, and I was contemplating on using 3 poles instead of 4, just because of that reason. I would say that this whole assembly weighs maybe 1.5 pounds.
Oh, okay.
Yeah, it's not really heavy.
Okay.
Yeah, it's not real super heavy. But I had to make it where I could release it up here and slide it up back and forth if I needed to do that, and then lock it back down. But right now it's in the spot, and I'm really praying I never have to move it again. Yes. So now, so I've got this antenna. Now here it is. This is my rather silly way of, oh, don't do this to me. I'm going to have to maybe, yeah, hold on a minute here, Gary. Let me see if I can get this other slide. I don't know why the program, let me just look real quick and see if I can find that. Oh, can you guys see this? Gary, can you see that?
Make it bigger.
Okay, can everybody see that?
Yeah.
Okay. Oh, good, good. I don't know why that I had that in that slideshow, and I don't know why it went away. So, so there you go. There's, you know, the right tool for the right job, right? Whenever I do this, I go out in the backyard. My wife has got the phone ready to call 911. So I have to let her know when I'm going to do this because I basically have to pick up the antenna at this. This is an orchard ladder, and then take this step ladder and put it under the rung there to get my elevation. So yeah, it's heavy though. I mean the antenna it is over 100 pounds. There's no doubt. So but I have to take it down. And the other thing is, when I built this, I had to actually put a little catwalk across the span so I could walk out and mount all this stuff because I couldn't step in the horn, or rather in the dish. So it was quite a journey mounting all this stuff because I simply couldn't step on this screen in here. So, but that's my current configuration right now to elevate the dish, and then of course slide the step ladder back and forth to give it its azimuth. So,
And you're pointing at the meridian, I'm assuming.
you know, right there, I think what I was doing is that was my first attempt because I knew this meeting was coming up and I was experimenting getting cygnus. And I thought, well, heck, I'm going to put this way up so I can get it earlier enough in the meeting where I could capture it. So, but it turned out I didn't need to do that. So I lowered it down. So it's only half that height.
But it's pointing like north-south, pointing at the meridian.
Yeah, yeah, it's pointing. Yeah, very close, Gary. Very
Okay.
close. Yeah.
Thanks.
All right. Okay, I think we got. Let me close that out. You still there, Gary?
Yeah. Why?
Oh, okay, okay. When I do things, I don't know if I close stuff out. Okay, let me bring this back up here. All right. Yeah, what happened is I closed out too many things. All right, so I think we're almost done here with this. All right, so all right, so that's how I've got it mounted. So now here, before I go any further, I'm going to show you the how I've got the. We talked about the 5 components, and this is how I've got the. This is the heterodyne, or the I still call it the back end, and then this is then piped in. This 70 megahertz IF then goes into here, and then comes out of here, and then it goes to the computer. So yeah, it's relatively simple to hook this part up here, and then, but this is all away from a lot of the AC. I tried to put it in a spot where that transformer you see down below, that isn't on when I'm running it. So let me see what else. And I got a picture here. That's the picture of the low noise amplifier. And as I mentioned, that comes from RAS as well. So let me give you now a picture of what my whole setup. Can you guys see that good enough?
It's kind of
You want me
small. If you go to the lower right corner, you see you can actually of your screen there, it says 132%. You can hit the little plus sign in the far. Well, yeah, that'll do it too.
Yeah, let me do it. Okay. Is that better?
It's getting there.
All right, let me do a little more. Yeah. How about that? Is that going to work?
Think so.
Okay. All right. So yeah, as you can see, I got the antenna over here, and I've got a 100-foot cable. Although my antenna was over right here, but because of our wind, I quickly realized that it was just moving it around way too much. So I had to actually move it back. So I'm only using about half that length of that 100-foot run. And then that, of course, then goes in the back of the observatory right here. And then the receiver and stuff are right up on that wall right there. So, yes. So that is kind of all the pictures I've got of this. Is there any questions about this that I didn't cover on this, or that I sounded kind of strange about? Okay. All right. Well, what I'm going to show you next is the actual system running. And I'll also play a movie of it, some data I took last night, 12 hours of data in Cygnus. So I'm going to go ahead and move this down. And right now, you're seeing real data being taken by the Spectre Cyber system. And so it's going to redraw here in a minute. And you can see it starting right over here. So, okay, we got some things here that we can adjust. I'm going to bring this down. So we got a mode here. We've got a continuum mode. We got a spec mode, which we're currently in. We can save our data points up to 999. That's an option I don't have. Rescan as it keeps looping and scanning. I can change the scan rate in seconds or points of seconds. Q, I don't have that feature.
Hey, Bill.
Yes.
What does spec mean for mode? What does that mean?
Okay, right now I'm in spec mode. Okay, and I'm going to show you I've got a movie on continuum mode that I'll show you and what that looks like. Okay. Yeah, so in spec mode, you'll see here we've got 0, and 0 is, and that 0 is right here. Rest correction is 0. I can go in there and change that if I want to. Okay, I do have the luxury of changing that. But for what I'm doing right now, you can see that rest is actually, if you drew a line, you could figure out the kilometers per second from that and say, okay, we're blue shifted this amount. And then as it keeps on going down and down and down. This feature here, I don't think I can do. This I can certainly do. This I can do, and I'll demonstrate these things here that we can do.
So that IFBW kilohertz, what does that represent? Do you know?
Yeah, I tried experimenting with this, and I can't get any meaningful changes on anything. I don't know if this system it's in this. That's one question I got to ask Carl about. That is about what that means.
Okay,
it looks like it definitely would apply to what we're doing here. But all right, so then we go up here, and the software then will provide you with a white background. This is where I can go from kilohertz to kilometers per second, which I have selected. I can plot zoom on. I can plot I haven't actually used this yet, so but it's there. I can do dots or lines. I can capture something, and it'll stop right there. Again, I haven't played much with that. This is a player. We're gonna do that here in a minute. The scan, I can start and stop. I can fix the scan rate, 1x, 2x, 3x, 4x, and I will demonstrate that too. It's on rescan, so it keeps looping around. Autosave I have off right now. I can scan from the player or save data, and this is this Q thing. Gary, this software was written really old, and the developers of this software look at Q is a very out of this world feature. And basically what Q is you can set a timer in the software and go to bed and have it come on at like midnight and lay in bed and go, wow, my system just went on at midnight. That's what Q is.
Okay, that's nice.
Yeah. It was really funny when I read it. But hey, it's there, you know. So we got our options here. We can right now we're working online, so we're communicating with the system. This is a feature that I don't have. This is this auto align. I don't do that. But Gary, there's a something that I want to. When you were talking about cold sky calibration, okay, so hit me in the side of the head, so don't forget that. I haven't played with this time. The time I use my GPS time. Then this one here is more what I use, spectral continuum, and then you got that selection we just talked about. And if you come in here, it brings up this panel right here. And so for tonight, I've got class demo, and this works in not the kilometers per second, but the other scale, which I'll do here in a minute. So you can set these upper and lower limits to how far you want to go off of frequency rest. The gain that what this actually is showing here is Carl put it, this is more of a zoom. So I can come in here, and if I put a gain of 0, it might be down here. But if I put a higher gain, what it's going to do is basically magnify the waveform. Now, when I asked Carl, and I said, hey, doesn't gain represent some sort of power or some sort of relative power? And I already knew the question of that, or the answer, I should say. He goes, no. He says that's very complicated to know, what kind of power you're actually measuring, because you have to do a lot of calibration, and you have to have known things before you can do that. But yeah, that's what it serves as here, is just more to where you can see more of the waveform, and that's why you gain it up in this scenario here. I got it set to 0.4 seconds. My frequency rest is 0 right now. Okay, and it's pretty simple. There's not a lot there that you can do.
Bill, what is the time step 0.4 seconds?
Yes.
That's not like an exposure time, is it?
No. Now here's the thing about this. Okay. And this is what I talked to. I'm going to get off a little bit on the square law detector for a minute. Is the square law detector is it was described as a capacitor charging, and then somehow discharging. And so that to me says, well, this is a system that is, he's gating it somehow and timing it such that he's taking a reading at some point in the charge cycle, and then reading that value off and then converting it to a power measure. But what he's actually doing is the square law detector is actually running continuously. And then what we're doing is we're just sampling off that continuous. how it works is I got it written down. And this is what he told me. The receiver output signal is sent to a square law detector, which doubles the output voltage each time the detected signal doubles in intensity. Yeah. Now, if you go to Dr. Google on there, there's a little bit different in there, but it's basically the same idea. And what he's doing is he's taking a signal and chopping half of that wave, and because it uses diodes, and but he's not really telling me exactly what it's doing. And I'm sure it's really complicated.
Is this a concept in ham radio as well, or is it just unique to?
Square law detection is used in a lot of radiometers, and especially when the signal is really low. That's what I recently learned. Now, the stuff that I worked when I was working, my radiometers didn't use that. They used something called focal plane arrays, which is it's a CCD, but it runs on indium gallium arsenide is the chemical element to see a near IR source, but that's another whole story. But anyway, anyway, that I took his word for that, and I said okay, because I told him what I was doing, but that's something on my what I plan on advancing on and getting a better understanding of how that works, and how much of that do I really need to know to make this thing work. So, any other questions about that topic? Let me see what else I can show you on here. That like I said, that's pretty much it. And then we come back to start again, and we can start our scan. Let me show you the other different things you can do on here. Gary, you asked for some other different the continuum. So let me go to a movie here that I recorded, and I'll show you the spec and continuum features on this software here. So we're going to go, this is kind of a little hokey in how this works, but we're going to do this. So I'm going to go ahead and grab something that I did here last night just for this presentation. So I'm going to capture the start of the sequence. You probably heard a noise on there. And then I'm going to go on here and pick an ending point, which is 590. I'm going to hit OK. It's pretty simple to do this. It's very, very simple. I'm going to hit on. Oh, what did I do? Let me do that again. All right, let me get player. I think what I did is I started the wrong spot. Let me just go down here. A lot of files. Okay, we'll start. Oh, no wonder why it didn't like me.
So each file represents a moment's capture.
A slice.
Okay.
587. Okay, we'll stop at 587. All right. We're getting somewhere now. Oh, I got to go down more. Okay. There we go. I promise. And oh, hold on. We're just going to do it this way.
Welcome to the Europa station. Please prepare for docking.
Pretty awesome, huh? All right. I promise this time it's going to work. All right. We're just going to go to 5. Okay. That's my ending point. All right. So here we go. This is about 6 o'clock it started. It goes all the way into the morning. You can already see a little bit of crest right there.
Was it pointing your Cygnus at this point? Or
Yes,
okay.
yes, this is pointing at Cygnus. And it's going through right now. And then we're going to go through that, and then we're going to get the tail end of the other side. All right, just start going up again here now. Looks a little different from the first one.
Yeah.
All right, let me show you one more thing here. What I'm going to show you is the continuum one now.
So that was what, spec?
That was spec, right.
Okay.
Now, let me see if I can find this. I'll tell you what, let me yeah. Okay, let me just go in and do it this way, Gary. All right, we're just going to do a plot right now. That's interesting.
Welcome to the Europa station. Please prepare for docking.
All right, let's try that again. Oh, I know why. All right, now let's go ahead and do. All right, we should now. See something here.
See, the step numbers are increasing.
Yeah, let's do this. We're going to change our gain to 16. Okay, you can see it coming off the side right here.
Yeah.
So basically what you'll see on this is that when you saw the signal coming up, the starting of the waveform, it'll happen at 0, and then it'll do all that waveform here, and then it'll just make a straight line outward is what it will do. Obviously, I don't have it set up right to do that. So yeah, that'll just keep going on that. So that I won't be able to get that to work. Okay. All right. So any other things about this?
Looks complicated compared to the scope in a box for sure.
Yeah, it is. And as I found myself, getting into this and saying, this was never my intention, I actually started really enjoying doing and putting the antenna together. But there is, as far as learning the electronics and stuff like that, I'm really relying a lot on Carl and my dad to help me understand that sort of thing, how that works. So.
Okay, any other questions for Bill?
Okay, let me zoom this out real quick.
Okay, well, that's probably a good segue, Gary, into what you were going to talk about with your experience out of CAC with it was scope in a box that you were using out there.
Right.
But I was going to mention here's Radio Astronomy Supplies, their website. You can find everything that I talked about on their website. If somebody wanted to buy a big horn, RF Ham Designs is one vendor that sells those big horn or big dishes. And then my email address, Pandora Observatory at gmail.com. And if you're any interested in coming over and seeing, come on, stop by. Stop by.
You're up in Flagstaff, right?
Yeah. Yep.
That radio supply that you're using there, where are they actually located?
They're in the deep south. I'm going to say around Missouri.
Ah,
Yeah. I'd have to get their address, but I think that's where they originate from. These guys are really helpful. Whenever I have a question, like I had today with Carl, he gets right back. And so whatever you want to do with this particular system, he's on it. He will really do a lot of help or get you going and understanding what is happening. So, yep.
Thanks, Bill.
yeah, thanks.
Yeah. Well, thank you for letting me do this.
Yeah, very interesting.
Yeah. All right. Should I send my screen back?
Yes.
Okay. Stop share. All right.
So last week we had the Evening Under the Stars, and it was last Saturday night. And that's something they do at CAC. For those who are not familiar, I guess, Bill, you may not be familiar. They invite the neighbors in the area, and people from Tucson actually come out. So these are people that don't know much about astronomy or they're interested in learning about it. And so I brought the my scope in a box, stuck it on one of these public pads, and surrounding me were several other amateurs with members with their telescopes. So and people just walk around and look between telescopes and talk about what they're looking at and stuff. So it's a lot of fun. So I thought, well, I'll bring the radio telescope and see how the how it would feel to try to do outreach. And the first thing I discovered was that all the telescopes that are to this, they're all mostly to the south of where I had set up. I got this tremendous amount of radio interference from the telescopes or the computers, or I don't know what it was. But Ed was there. He was right next to me, and he heard me lamenting about how I couldn't get very good quality signals because the RFI was just dominating. But we did some various and sundry things to try to fix it. Got it a little bit better. But that was my main frustration, was that, and I think, Sandy, you had mentioned that you had done a star party with a bunch of RVs nearby, and you had the same problem. So these things are really sensitive, and I suspect it's the side lobes that was picking up these things, but that's something to keep on, trying to figure out. But I did have people come by. When they come in, they have an orientation where people, some of the TAAA folks, let them know about what they're going to be seeing. The telescope's got a 40-inch, 9-inch beautiful refractor, and then the pads with the various telescopes. And I guess they must have told them about the radio telescope, because some people would come up and say, "Hey, is this the radio telescope?" And I say, "Yeah, that's it." And then I started to show them some pictures or some images of graphs that I took of various areas, and I found it to be really challenging to try to find analogies, and that's something I think that if we're going to do outreach, we're going to have to figure out how to explain what people are looking at, because they see a bump. It's not like this beautiful picture with beautiful colors and stuff like that of a nebula or a galaxy. And so I was trying to explain about the focusing on the radial velocity, that it was showing that the various and sundry little bumps corresponded most likely to different spiral arms. And I think some people were kind of getting it. I had some that are asking some pretty good questions. But again, it's being the first time I really done this, I just found it to be very challenging to try to explain it. A little bit later, a family came up with little kids, and they were all looking at the screen, and I could tell that they had like the deer in the headlights, like they had no idea what they're looking at. And I was trying to explain, and the father was, I could tell he was like, well, he was kind of hesitant asking questions, like he wasn't sure how you're going to ask the questions about what he was seeing. I tried to explain it was essentially the telescope's like one humongous pixel that's looking at the sky. And he asked, well, how do you make a picture? And I explained that you have to point the telescope at various parts, like in a nice orderly way, and then put all those, those images, the brightness, into some like a two-dimensional diagram that kind of indicate what you're looking at. So I think he got that, but I think it's probably a good thing. I'm going to look on YouTube for other resources. Maybe some people, like in Sarah, maybe they have resources on how to do outreach in a way explaining some of this. But there was some interest, but I think I probably ended up confusing everybody. So Ed, you came over. I mean, I don't know, did I confuse you? I know you're a ham background. I don't know if I confused you or not with what you were saying, but I don't know. What was your take on that?
Well, I'm a technology nut. I love technology. So anything dealing with that, I really like. So I know so little about radio astronomy, but what I see is very intriguing. And I definitely see what you're saying about the spikes or specific spots with specific, energy and particular wavelengths and representing that. My interest there would be like mapping broad areas of the sky and getting multiple spikes and trying to correlate those to what is actually there, and not making a picture like people are asking about. I think I got that, but it is very intriguing. That's why I'm here tonight. Try a little bit more, learn a bit more about that. And I spent some time today looking through websites and looking at sources of equipment and how it's put together, and what is what and why is it there and how does it work. And I have a ham background. I haven't done it for years, but I do know something about, antenna design and theory and that type of thing. So anyway, so I'm learning. Thanks for your patience and your input.
Yeah. So I didn't totally confuse you is what you're saying.
Absolutely not.
Okay. Anyway, that was my experience. So, Sandy, you had a similar experience, didn't you?
Well, I've taken a different approach. By the way, before we get into that, I'd just like to say that to those of you here, it is worth your while to join SARA. That's a Society of American Radio Astronomers, and they have people that do all these projects, and they have a very interesting forum where you discuss all of these issues. And I highly recommend that we all join it, actually. It's just really got a lot of good stuff to it. My approach to like outreach is to think in terms of who it is that I'm trying to reach. And it wouldn't be Ed Jacoby, actually, particularly. I'm thinking of like a more technically naive group,
Mhm.
not somebody as smart as Ed. So I think the scope in a box is going to be hard to do that with, but what I think will work well. I had meant to try this out, but we got smoked out up here. But I think the itty bitty telescope is more the direction I would go. So the itty bitty telescope basically it's used to point at the sun, and when you get on the sun, it feeds the signal to a little signal finder that starts buzzing. So our idea was to take this to we have an Earth market each Saturday, and families show up and kids show up, and we usually have little astronomy games for them to play and so forth because we run like a Science for Everyone a booth there. And I'm talking about a group up here called Selkirk Alliance for Science. And what I thought would be the way I'd do it is to bring the itty bitty telescope out, have it pretty much aligned close to the sun, so the kids wouldn't have to move it too far. But it's on a like a you can move the scope around, and behind that have a big pictorial of the electromagnetic spectrum. So teach kids that, the sun actually doesn't just put out light that we see, it puts out electromagnetic radiation across all kinds of wavelengths. And you can see it with different types of devices like the itty bitty, and show the kids how to move it around. And when they get the dish pointed at it, it'll pick up the radio signal that's being emitted by the sun. So in other words, to try to teach them and teach the younger kids that a little bit about electromagnetic radiation and what we call uh, visible light is just a little teeny slice of that electromagnetic spectrum. So that was really what I thought would be my approach to getting out and doing some outreaches. It's very easy to operate the itty bitty telescope. It's quite portable. Um, and like I said, it wouldn't be measuring the rotation of the galaxy or any of the fancy stuff like that. But it'll get people thinking about a little bit about what radio astronomy is. Also, you would go out during the day with it, of course. You wouldn't do this at
Yeah.
night. So that was my thought about it, about outreach.
That's a good idea. Very good idea.
Because most people, that the first thing they're going to want to do is to say right off the bat, where's the picture? So, well, the picture is this graph that shows this spike.
Right. Yeah.
By the way, Bill, I'm really struck by how similar your system is to what the itty bitty, or not the itty bitty, the scope in a box is doing. The software that we use is the SDR Sharp with the IF plugin. And that IF plugin is doing a lot of what you're showing on your graph, that spike. But of course, for that scope in a box, it's a much smaller dish, so the beam is a lot wider. You're picking up, as Gary was talking about earlier, you're picking up a lot more stuff. You're picking up really the
Yeah.
galaxy itself. So the Milky Way. I don't know what the answer, Gary, to bringing the scope in a box out there would be. That would be a wow, like that Saturn wow that the public has. I don't think that's
Yeah.
going to happen.
Yeah. I don't know. Like I said, I think looking at the Sarah site, or they have I guess they have a YouTube channel. They might have some pointers on how to, or suggestions on outreach.
Yeah.
But
Yeah,
I was frustrated a little bit.
Well,
Yeah.
one thing I would say for sure is, and it was your experience too, mine too, is that the radio frequency interference, you need to get yourself into an isolated spot. So what might work better is to actually locate the dish on the other side of the bunkhouse, the warming house, and get it out in a place that's really pretty quiet and try to block it. But putting it out on the pads is probably not the place to go with it. It's too much
Yeah.
interference.
Yeah, the farthest the way I could go would be the best, but then probably no one's going to come by.
Well, you know what you could do is take maybe run it out back totally on the other side, and then have the feed line come into like the warming house and actually do the showing of what you're up to in the warming house with your display there.
Yeah. Or have another laptop when that would actually run the system at the telescope, and then have using the internet to access it with remote desktop.
Yeah, yeah,
Something like
exactly.
that.
Yeah,
Yeah.
yeah.
I
And
might-
you've got that right in your backyard, right?
yeah, I do. I'll just bring my backyard with me. Anyway,
Hmm.
Yeah, but that's a good idea to take a look at maybe some videos of what other people are doing for outreach.
Hmm.
again, coming up with analogies to describe what they're looking at. Your idea, I think, is very, very good. A little more background to kind of help build up their understanding too, like to start with something that people can all understand, and then add to that, just talk about how light is electromagnetic spectrum, the radio waves are similar.
Yeah. Yeah, actually, my target audience ranges in age from about 7 to 15,
Hmm.
Okay.
is what I was thinking. Although I'm always surprised at how many adults uh, don't really understand the electromagnetic spectrum either. But
Yeah.
and then I asked the kids, okay, so what do you think things would look like if your eyes, instead of looking at this band, could look at totally different parts of the electromagnetic spectrum? What would our world look like? I mean, there are radio waves all over the place. So
It's interesting when I use my other telescope for the photometric bands. I was asked one time. I said, yeah. So they basically said, well, when the sun goes down, it gets dark. I said, in reality, it's never dark. It's never dark. I mean, there's always electromagnetic energy going all the time in the near IR, the far IR, and of course in the radio spectrum and all that. And for them to go, no, it is dark. I said, no, it is not dark. Only at absolute zero, theoretically, it'll be dark.
And we'd be
Yeah.
dead.
yeah.
That's that.
And we'd be dead.
Yeah, it'd be dark, right?
Oh, by the way, Bill, you were talking about getting 2 SID kits.
Oh yes.
So I got the SID kit. I assembled the antenna. Like I said, I've got it in my basement, a loop antenna, made a
Uh-huh.
framework. And so it's running right now. It's down in my basement. It's doing its measurements. But
Uh-huh.
I was curious, why did you get 2 of them?
Well, I got 2 because we have some really freaky lightning out here. Lightning strikes are really bad. If you saw that picture I showed you of my observatory, I've got lightning rods all over it. So lightning is a big issue out here, and but I did. I mean, they were like $40, so I got 2 of them, and because I might make one myself, but my wife's going to head that up right now, and but yeah, we're going to do that. But I'm thinking, well, geez, I got 2.5 acres, and we were talking about, background noise affecting our signal that we want to capture. And where I'm located, the next house away from me is more than 100 feet away. And between my back lot and the next house is 4 acres away. So I have a lot of space. And I was thinking, I was telling my dad, I said, well, man, I'm just going to put a big loop antenna out there at the horizontal and just wrap the I think they say 400 feet of wire that you need to make this thing. And I don't know what that would be equivalent to wavelength, but to do that and just wrap that around at like a 600-foot round circle or a big square or something like that, and just see what kind of results you get with
Well,
something.
that'll be interesting. We'll have to compare notes there. Mine is a loop antenna.
Uh-huh.
It's built on a frame that's probably about 4.5 feet across, so it's a big square. And
Yeah.
it's 25, actually it's 26 loops. My wife helped me wind it. So it doesn't have to be some great big huge loop. It can be fairly small. And
Okay.
you're right, it's 400 feet of wire.
Yeah. Yeah.
And
Well, I joined Sarah, and you're right. They've got a lot of stuff on there. I mean, you could just spend your whole day on there and look at stuff people are doing.
yeah,
And they mentioned in there, the bigger the antenna, that theoretically you're going to capture more signal. But there's the downside is that if you use more wire, then you're going to create more resistance. So
yes.
there's going to be a trade-off in just how big you can do it. And that part of it, I'd love to experiment with. And just
Well, it sounds like you're
yeah.
thinking about making one great big loop.
Yeah. One great big loop.
Hey,
Right.
mine is not. It's 26 turns on a frame. So
Yeah.
so you can do it. In fact, actually, that's one of the things they advertise about it is that you can actually put your whole rig up in a fairly small space. Because mine actually was their large configuration, and
Oh,
they have a smaller one where instead of it's maybe, I don't know, 2.5 feet across or whatever,
I see the
little
picture.
frame.
Yeah.
Yeah, and
Yeah.
and they
Real
loop
small antennas. Right.
they
Right.
and they loop it 50 times. So yeah, we'll have to keep up with. That's another presentation, I think.
That would, yeah, that would be a really good thing to try out different antennas
Yeah,
and to be able to capture those transmitters.
yeah.
To be able to get those transmitters and be able to, having one lay flat down the ground or above the ground, maybe 10 feet on poles in a great big loop to me, would be interesting.
So this is I know we're getting kind of astray here, gone down
Yeah.
this SID thing,
Yeah.
but I never knew this before. But apparently there are these transmitters that we have in various parts around the earth that are used to communicate with submarines, and the
Yeah.
reason
Yeah. 25 and
The reason
yes.
the reason being that if you transmit on a very, very long wavelength radio wave,
Right.
well, now hams know this, that the longer the wavelength, it can actually go around corners, right?
Right.
It can go around
Ionis
buildings. So,
skip.
but if you get it long enough, I didn't know this, but you can it'll go through water just fine too. So
Right.
they use these to communicate with submarines. Well, what this SID project does is you make this antenna that picks up these transmitters, and I've seen some pictures of these transmitters. They have transmitting antennas that go from like one mountaintop to another. That's incredible.
The antenna, the actual wire is like 4 or 5 kilometers long
Right.
for halfway.
So what you're doing is you're monitoring these very long wavelength radio signals that are being put out by these beacons, and
Yep.
every once in a while you'll get a spike, and the spike is because of some sort of disturbance to the ionosphere, and that can then be related basically to solar storms, either a
Right.
CME or a flare or something like that. So that's what that whole project is about. And Sarah actually has a whole kit that you can purchase. You must have only purchased part of it because the
Yeah.
whole thing is like $140.
Yeah. I did. I think I got the wire and the receivers. Hey, one more quick thing though, that very important point when you were talking about the outreach stuff, and I mentioned this
Yeah.
in the last meeting. By association, you go out there with a solar telescope and with a radio telescope, and you say, hey, look, we got a telescope out here, and here's what we're seeing, and here's what we're viewing in the radio spectrum.
Right.
And I thought with the space weather, a friend down the street, he's got a really nice solar scope. I said, John, I said, why don't we do this? When I see something in my space weather spike, you tell me what you're seeing in your solar scope.
Well, you know, you're going to have to make that loop a lot shorter than what you have in mind then to be able to move that up. Okay. And like I said, I got off topic here. So
Yeah, yeah.
anything else anybody wants to bring up at this point? Okay, well, Bill, thanks a lot for that tour of your observatory. That was very interesting.
Yeah, I'm glad I could do that.
And
Yeah.
we'll keep working on some of these other subjects like outreach.
Yes.
Okay, well, in that case, I am going to stop the recording